Good morning, students. Students, yesterday we did some questions based on exercise 6.1, that is rate of change of quantities. Today also we will do some more questions. So the first question is, a ladder which is 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? See, this is the wall, this is the ground, and a ladder of length 5 meter. The length AB of ladder is 5 meter. When the bottom of the ladder is pulled along the ground, obviously when it will be pulled, then the height will be decreased. We have to tell at what rate is the height decreasing. Means dx by dt is given to you. The bottom of the ladder is pulled along the ground away from the wall at the rate 2 centimeter per second. Suppose this x, the foot of the ladder is x meter away from the wall. This is the foot of the ladder. Now suppose it is x meter away from the wall, right? And this is the height of the wall, OB, right? This is y. Then dx by dt is given to you 2 centimeter per second. And we have to tell dy by dt. We have to find dy by dt. Now see, in triangle OAB we will apply Pythagoras theorem. This foot is, it is asked when the foot of the ladder is 4 meter away from the wall. Means x is given to you 4, AB is given to you 5. You have to tell y. So applying Pythagoras theorem, we will get x square plus y square is equal to 25. It means y is equal to 25 root 25 minus x square. Now we have to find dy by dt. So it will be derivative of root is 1 by 2 root, then derivative of 25 minus x square is minus 2x, and derivative of x is dx by dt. Now we will keep the value of x and dx by dt. What is the value of x? 4, right? It is given now when the foot of the ladder is 4 meter away. So x is given to you 4 and dx by dt is given to you 2. So by putting these values of x and dx by dt, we will get dy by dt minus 8 by 3 centimeter per second. And this minus sign indicates that the height of the ladder is decreasing. Height is decreasing at the rate 8 by 3 centimeter per second. Negative symbol indicates that height is decreasing. Clear? Now next question is, sand is pouring from a pipe at the rate 12 centimeter cube per second, and the falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? Sand which we have poured from a pipe, that when it will fall on the ground, it will take the shape of cone, right? Now at what rate sand is pouring from the pipe? 12 centimeter cube per second. Since it takes the shape of cone, so suppose V is the volume of the cone, R is the radius, and height is small h. Then what is given to us? With the help of these units, we can say that dV by dt is given to us, right? So dV by dt is what? 12 centimeter cube per second. Now what is the volume of the cone? 1 by 3 pi r square h. And this h is what? H is r by 6, 1/6 of the radius. So from here r is equal to 6h. So we will put the value of r here, and it will be 6h, 1 by 3 pi 6h whole square into h. Now we will differentiate it with respect to t, because we have to find dh by dt. It is asked now how fast is the height of the sand increasing. So we have to find dh by dt. So differentiating this equation star with respect to t, we will get 12 pi 3h square dh by dt. Clear? So it will be 36 pi h square dh by dt, and finally h is given to you 4 centimeter, height is given to you 4 centimeter, this height is 4. So we will put the value of h and dv by dt in this equation. So we will get dh by dt, and that will be 1 by 3 pi h square, and after putting the value h is equal to 4, we will get it 1 by 48 pi centimeter per second. So this is the rate at which the height of the cone is increasing. Clear? So in this way, in these type of questions, one rate of change of quantity is given to you and you have to find the rate of change of other quantity. Tomorrow we will start with tangents and normals. Thank you.